In this experiment I'm going to use a upgraded plug. Here's the big plug. Our circuit is going to be the same. The transformer here that you see on the top, that's the transformer, number 1 transformer. Now we'll go have a closer look here at the big plug. Same idea. Say sealed unit. On top I'm running with a Motormaster Platinum spark plug. Here is our pressure baffle. Shot of the stand. Perhaps one day I can get a better camera. A little kind of a peek inside. Have a look at where we connect up. Okay, now we're going to fire it up. Here's a look at our milliamperage. Pan across here. Have a look at the transformer that I'm talking about. Here you can see it highlighted in red with a light. I have also a little light on there just to show what's going on. Now we'll have a look at the scope and just try to adjust it up here. And this is on our first transformer. Okay, our frequency is about 408 Hertz, and this other meter is showing degrees Celsius. We're starting at about 24 degrees Celsius. This is oscilloscope number 2, and essentially what we're looking at here is what's going on across the actual HHO plug. The readings on the scope are ×2 ×10. A little bit hard to see here, but you might be able to catch it. You can see that the bubbles are streaming off the end. Here's a closer look at the milliamps we're pulling, about 120. Now here we're up to about looks like 180 × 2, so 360 volts, and our water's fracturing. Now a little bit further into the experiment, we can see here that we're at about 640 volts. You can see the sine wave that's happening. This is DC. So this is a DC component with an AC sine wave on top. Okay, we'll have a look at our temperature now. You can see we're about 35. This is our first transformer. It's kind of the sine wave that's coming off it. We'll have a look here. Here's the light. You can see it's about the same brightness. This basically just shows how much resistance is flowing. Again, a shot of our milliamps. Now what's going to happen is there's going to be enough gas buildup in the plug that it's going to start firing. So here you can see right away the milliamps drop. So now we're down to maybe 75 milliamps, and you can see that on our transformer we can actually see the firing going on there. We'll go over now and we'll have a look and watch our temperature, and we can see that our temperature is now starting to climb. Still around the 400x frequencies. But now let's look at scope 2, and we can see that we're way over 2000 volts here. And you can see there's kind of a lower portion, and then it ramps itself up and fires off. Now we'll have a listen, and you can kind of hear it firing, and at the same time you'll see it in the scope. Have a look here at the milliamps. You can see it's down about 75 milliamps. Now let's have a look at the actual action that's going on in the plug. And as you can see here, it's not a blue spark like a standard spark, but it's red. And the trick is to get the best heat is to get it firing so that you get that nice orange glow inside there. And as well, you can kind of hear it pinging away through the voltage multiplier and the noise that the plug itself is making. Now we're going to slide over here and we're going to take a look at our temperature. Look at our temperature here now. We're 44 degrees, 45 degrees Celsius, about 431 Hertz. See if I can zoom in here and show you the action. I'm going to play around a little bit with the frequency and you can see how we lose the firing. Now towards the end of the experiment, here's what we pretty much ended up with, around 46 degrees Celsius. Let's have a look at this crazy multiplier here. Here's our high voltage multiplier. Now I added on a vessel on the top here so that I could fill it with an exact amount of water and take measurements. As well, I added in this area here so that I could collect the gas that seems to be forming that doesn't explode inside the HHO plug. Here you can see this is where I connected our baffle to allow for expansion and contraction. And again, here's the vessel on the top that we're going to fill with water and take measurements of heat. Alright, I inputted all the data that I collected over many tests, and here's kind of a graphical representation of what's happening. I have another one here, a couple more tests. I'll zoom in a little bit more on this one and you can kind of see the general idea. So basically we're starting out with 200 milliamps at about 23 degrees Celsius. Once the plug starts firing, you can see that the milliamps drop and the temperature starts rising. Now I'm going to do some calculations here to figure out the exact work that we're getting. So here's our formula for figuring out work in joules with 21 grams of water over a time of 30 minutes. And what we end up getting is we're using 15 volts with about 0.07 amps that I've calculated out to be. Now in this video I really only showed a sample of some of the experiments that I did. I worked on this quite hard and I still couldn't get any more heat out in watts than what I was putting in. As you can see here, 0.7 watts basically from the heat of the water over time, and I was using 1.05 watts. So the conclusion of this experiment is that I haven't really seen any gain in energy at all. I'd also like to revisit one of my last videos where I showed that the light seemed brighter coming back from the plug than it did what it was drawing. This is basically a trick or a falsity. Because of the difference in voltage, the light does seem brighter. However, if you actually took measurements using resistors and determining the heat off the resistor, you would find out that there's no over unity there or any increase at all in the amount of energy being produced. A lot of guys fall for this. When I first started out years ago, I fell for this quite a bit, but I learned to take proper measurements, and this doesn't mean that over unity is impossible. It just means that we need to look at proper measurements and trying different things. Physics gives us a lot of base to go by, but physics does have a few holes, so we'll just keep on trying.